Hello everyone, I'm Mr. McBrien. This is SPH3U, Gravitational Potential Energy. So from the Ontario curriculum, we have some learning goals that we're going to explore today. We're going to talk about the concept of gravitational potential energy. We're going to solve some problems involving power, energy, and time. And we're going to conduct an inquiry. As a matter of fact, I'm going to talk only a little bit here today to give us time to do an inquiry involving the relationship between power and work. So today's agenda, we're going to learn about the value of elevation. We're going to learn how to calculate gravitational potential energy. And we're going to do an inquiry talking about how many calories we burn doing a familiar activity, walking up and down stairs. Okay, so the value of elevation. We know this intrinsically, but what we want to do is think about this in terms of physics. And in physics, we look at any object with the opportunity to fall, and we can say it has energy. And we can think of lots of examples. A skier at the top of the hill getting ready to go down. A hydroelectric dam, a wonderful example. Or maybe a more fun example, a roller coaster at the summit getting ready to go to head down towards a loop. You can probably think of a lot more examples. Now, we can talk about working against gravity in the same terms as the energy that an object has. To lift an object, a distance delta h at a constant velocity, the applied force that does the work has to be equal in magnitude but opposite in direction to what? Well, it has to be equal to the weight of the object. And so we can say with work equaling force times distance from previous, if we consider the force to be equal to the weight of the object, the force is just equal to mg. So we can convert force times the change in distance to mass times gravitational pull times the height that the object is lifted. It's a pretty simple substitution. So what we can say is that the work we're doing is increasing the object's gravitational potential energy. And we can write it as delta Eg equals mass times g times delta h. Okay, and we can simplify that further. Gravitational energy equals mass times g times height. And that's just accepting that the height itself is considered versus some reference point with height 0. And as we've done several times in this unit, in this class, we have to designate a reference point. So we might designate the floor of the building as height 0. And that's relatively arbitrary, of course, because we could have chosen the basement. We could have chosen sea level. We simply have to designate that before we start to work. Okay, so an example calculation. An object of mass 3 kilograms is lifted at constant velocity from a height of 1 meter to a height of 2.5 meters. What's the increase in gravitational potential energy? So, we've got a mass of 3 kilos. Our delta H is 2.5 meters minus 1 meter, or 1.5 meters, and G is 9.8 meters per second squared. And what we're asking is, what's the gravitational potential energy? So, Eg equals mgh equals 3 kilograms times G times 1.5 meters, or 44 joules. Pretty simple calculation. Now, having that in hand, we're now in a good position to go and do the inquiry activity. So please, if you're following along at home, find yourself a set of stairs, print out the inquiry activity, and go ahead and do those calculations. And once you're finished that, please read through the textbook, page 233 to 235, and do the problems shown on the screen. So, what did we learn today? We learned today the value of height. We learned how to calculate gravitational potential energy. And we learned in our inquiry activity the work that's done going upstairs in calories and in Big Macs. That's all for today. Have a great day.